Good morning, my dear students. Welcome to Unacademy. Welcome to Kreatryx channel and welcome to Impulse batch. Before going to start today's session, let me introduce myself. I'm KV Swamy. I've done my MTech in Systems and Signal Processing. I have 12 plus years of teaching experience and my favorite subjects include Signals and Systems and Communication. Currently, I am associated with Unacademy, and if you want to purchase any course on Unacademy, you can use my code KVS Live, with which you will be getting flat 10% discount. Any course on Unacademy you can purchase using the code KVS Live. First of all, we'll observe what are the various courses for GATE we are having in Unacademy. Basically, we are having two types of subscriptions here, namely the Plus subscription and the Iconic subscription. In the Plus subscription, the student is exposed to live classes, crash courses, weekly tests, doubt solving sessions, and batches are conducted in both English and Hindi. If a student is not comfortable with English, he can take the batch in Hindi, and if a student is not comfortable with Hindi, he can take the batch in English from his choice of educator. And we have rank improvement batches as well. Coming to Iconic subscription, a personal coach is allotted to the student who will prepare the study planner. Study booster sessions are there. Separate test analysis is taken for every student. Dedicated doubt clearing instructors are there, and preparatory study material is also given to the students. Now, if you look at the fee structure, in Plus subscription, GATE or ESE preparation for 12 months, that is 1 year program, it costs around 27,225 rupees only after applying the code KVS Live. In Plus subscription, GATE or ESE preparation for 18 months, that is 1.5 year program, this costs around 34,650 rupees only after applying the code KVS Live. GATE or ESE preparation in Plus subscription for 24 months, that is 2 year program, this costs around 39,600 rupees only after applying the code KVS Live. Coming to Iconic subscription, GATE or ESE preparation for 12 months, that is 1 year program, this costs around 45,225 rupees only after applying the code KVS Live. Iconic subscription, GATE or ESE preparation for 24 months, that is 2 year program, this costs around 66,600 rupees only after applying the code KVS Live. Now let me tell you an important information that as every week Unacademy is going to conduct an online exam. This week also, the coming Sunday also, this is going to happen, that is on 30th of May. 30th of May at 11 AM. See, Unacademy is conducting online exam, Unacademy Combat, for the branches of Mechanical, Civil, Electrical, Electronics and Communication, Computer Science and IT. The advantage with this exam is if your rank is in between 1 to 3, you will be getting 100% scholarship in Plus subscription. If your rank is in between 4 to 10, 75% scholarship you are going to get. If your rank is in between 11 to 50, 50% off you are going to get. And if your rank is in between 51 to 100, you will be getting 25% on the Plus subscription. And this is about Unacademy Combat. And these are the new batches which have commenced on 12th of May for PSUs. Booster batch for HAL ECE, booster batch for RSEB ECE, booster batch for UPRVUNL ECE, and booster batch for DFCCIL ECE. Okay, you need not pay anything for these batches. If you take the subscription, these batches become free for you. And these are the new GATE batches which have commenced on 12th of May. Ascend batch for 2023 electrical, Evolve batch for 2022 electrical, Ascend batch for 2023 ECE, and Evolve batch for 2022 ECE. So you can enroll today using the code KVS Live. So let's switch to our topic. Good morning, Vamsi, Nitish, Adarsh, Shashi, Harish. All of you, give your attendance by pressing the like button first. Give your attendance by pressing the like button and share the session. Share the session. Okay. See, if you remember in the last class, let me give you a small recap of the last class. Good morning, Vishal. See, in the last class, we were looking at the concept of Laplace transform. Laplace transform. Laplace transform is the generalization of continuous time Fourier transform, will say. Generalization of continuous time Fourier transform. See, there are some problems with continuous time Fourier transform which can be rectified in Laplace transform. And what is the expression for Laplace transform? Here, given a signal x of t, its Laplace transform is denoted by x of s, capital X of s, where s is a complex quantity given by sigma plus j omega. Here we will put a double side arrow, means x of t forms a Laplace transform pair with x of s. From the signal you can go to the Laplace transform, and from the Laplace transform you can get back to the signal, and the analysis equation are the expression used to find out the Laplace transform is given by x of t e power minus st dt over the integral minus infinite to plus infinite. And what is the expression for inverse Laplace transform? 1 by 2 pi j sigma minus j infinite to sigma plus j infinite x of s e power st ds. And I told you that we won't be using this inverse Laplace transform expression, rather we will be finding the inverse Laplace transform using partial fraction expansion only, right? Good morning, science talks. Now, what is the relationship between Laplace transform and continuous time Fourier transform? Remember, your Laplace transform is simply the continuous time Fourier transform of x of t into e power minus sigma t. See, here in Laplace transform, along with the imaginary component omega, we are going to include a real component sigma, and in time domain that has the effect of multiplying the given signal x of t with e power minus sigma t. And what is the convergence condition for Laplace transform we have seen? Laplace transform convergence condition is this signal x of t into e power minus sigma t must be absolutely integrable. This is the convergence condition for Laplace transform. And the values of sigma for which this expression convergence is nothing but the region of convergence. And after that, we have seen that Laplace transform converges to continuous time Fourier transform on the imaginary axis, or on the imaginary axis Laplace transform and continuous time Fourier transform become equal. And we have seen the Laplace transform for basic signals. The first signal what I took was e power minus at u of t. What is the Laplace transform we got? 1 by s plus a. And in Laplace transform, always we must find out the ROC along with the Laplace transform expression. We must find out the ROC also. How you are going to find out the ROC? The simple technique is, in Laplace, see, before coming to Laplace, our signal is e power minus at u of t. Now after coming to Laplace, it gets multiplied with e power minus sigma t. So this becomes e power minus of a plus sigma into t u of t. Now here, what should be the value of sigma such that this signal converges? Means sigma plus a must be greater than 0. Converges means it must decay. If I take sigma plus a greater than 0, then only the overall signal will decay, or sigma greater than minus a, or real part of s greater than minus a. For any signal, you can get the ROC like this. So, good morning Ranjit. ROC is sigma greater than minus a. And we found out one more signal, minus e power minus at u of minus t, which has the same Laplace transform 1 by s plus a, but with ROC sigma less than minus a. And we plotted the ROC also. Suppose if I take the first one, see, for plotting the ROC, we will take a complex S plane, real axis, imaginary axis, and here in this S plane, I am not audible. Am I audible now? Now, in order to plot, please give me whether my sound is clear or not, all of you. Voice is clear or not? Please give reply. Okay, okay. Ranjit, please check your device once. Okay. Observe here. We look at the poles and zeros. See, from the Laplace transform expression, poles are nothing but the roots of the denominator and zeros are nothing but the roots of the numerator. So here for the first expression I am having pole at S is equal to minus A. And how to draw the ROC? Along the pole we will draw a dotted line, we will bypass the pole. The reason for bypassing the pole is that ROC should not contain any poles, and for all values of sigma greater than minus A, this is defined. So this is the ROC, we will draw like this. Why we are drawing this vertical lines means we have some certain properties of ROC according to which ROC must be parallel to j omega axis always. ROC consists of strips parallel to j omega axis. Right, in this way we will try to plot the ROC, and you can plot the ROC for the second signal also, minus e power minus at u of minus t. What will come? So take the S plane sigma j omega. First of all locate the pole, zeros are not there, pole is located at S is equal to minus a. How to get the pole? Roots of the denominator. Along the pole draw a dotted line, bypass the pole, and for all values of sigma less than minus a, this is ROC. And remember, ROC should not contain any poles, but ROC may contain zeros. In ROC, zeros may come, but in ROC, poles should not come. And what happened here? If I substitute A is equal to 0 here and A is equal to 0 here, so if A is equal to 0 here, this becomes u of t, 1 by S, ROC is sigma greater than 0. What happens if I put A is equal to 0 here? Minus u of minus t, 1 by S, sigma less than 0. Or we can say that the signal u of t and minus u of minus t are having same Laplace transform. Again they differ in ROC. Yes, you can get aspirant, you can jump, no problem. Just follow our classes, you won't get any issue, right? And we have seen that what is the Laplace transform for e power at u of t? 1 by S minus a, ROC sigma greater than a. And what is the other signal which has the same Laplace transform as this one? Minus e power at u of minus t, 1 by S minus a, ROC sigma less than a. Here also if you substitute A is equal to 0, you will get the Laplace transform for u of t and minus u of minus t. I think this was the last discussion. This was the last discussion. See, for this signal also, if you want to get the ROC, what I said, multiply the signal with e power minus sigma t. So what happens? Our overall signal becomes e power a minus sigma into t u of t. Now for the convergence, this signal has to decay. Decay means what? A minus sigma must be less than 0, then only it will decay, or a less than sigma or sigma greater than a. That itself is your ROC. Suppose I want the ROC for u of t. In Laplace transform, what will happen? It gets multiplied with e power minus sigma t. For what values of sigma? This expression converges is nothing but ROC. So sigma, if I take greater than 0, then only this will converge, because if I take the value of sigma, some value of sigma to be 2, e power minus 2t u of t, yes, it converges. So ROC is sigma greater than 0. Sigma greater than 0. Right. Next question, the next topic is, listen carefully, Laplace transform of unit impulse. Unit impulse. Laplace transform of unit impulse. Unit impulse means what? Xt is equal to del t, no? Xt is equal to del t. So what is the shape of the signal? Del t. Continuous time unit impulse signal. Hope you remember this signal. What does this one represent? Area or strength of impulse. Now, unlike other signals what I took, what is the difference between the other signals and this signal? See, the other signals e power minus at of t minus e power minus at of minus t, e power at of t or minus e power at of minus t. The previously discussed signals are infinite duration signals, whereas impulse signal del of t is what? Finite duration signal. First observation. Finite duration signal. The previously discussed signals are infinite duration signals, whereas impulse signal is finite duration signal. Okay, that is the first point. Now, in order to get the Laplace transform, what we are going to do, observe here, very important concept is going to come. Listen carefully. Now, substitute x of t is equal to del of t in the analysis equation. So, Laplace transform is equal to integral minus infinite to infinite del of t multiplied with e power minus st dt. Simply substitute x of t is equal to del of t in the analysis equation. Now, we have to simplify this integral. How to simplify? Make use of the fifth property of impulse, that is sampling property. Do you remember the sampling property of impulse? What does it say? Integral t1 to t2 x of t into del of t minus t naught dt is equal to x of t naught if t1 less than t naught less than t2. If the shift t naught lies between the integration limits, simply substitute the value of shift in the given signal. Now, following the same, I can arrange my integral as e power minus st into del of t dt. Now, what is there in place of t naught? 0. Does 0 lie between minus infinite infinite? Yes. Simply substitute the value of 0. E power minus s into 0, which is nothing but 1. And remember, Laplace transform of del t, impulse signal is 1. Laplace transform of impulse signal is 1. And already we have seen that in Laplace transform, along with the Laplace transform, we have to specify an important thing, that is nothing but your ROC. And remember, my dear students, here ROC is entire S-plane. ROC is entire S-plane, will say. ROC is entire S-plane. Why entire S-plane? Means we have certain properties of ROC according to which if the signal is of finite duration and absolutely integrable, then its ROC is entire S-plane. Let me write very important note. Listen carefully. If the signal is of finite duration, impulse signal is of finite duration, no? If the signal is of finite duration and absolutely integrable, yes, absolutely integrable means absolute area under the signal must be finite value. Yes, impulse signal satisfies both these statements, then ROC is entire S-plane. If the signal is of finite duration and absolutely integrable, then ROC is entire S-plane. Now, a question comes to your mind that why entire S-plane? Why entire S-plane? Why ROC is entire S-plane for a finite duration signal? In order to know that reason, first of all, you must know what is the concept of ROC. Observe here. Listen carefully. Suppose if I take this signal e power minus 2t u of t. Forget about impulse signal. We'll come to impulse signal after a short while. Now, we are try to understand, we'll try to understand what is this ROC. Suppose if I take the signal e power minus 2t u of t, because let me tell you my dear student that if you can understand Laplace transform well, Z transform will become easy for you. Buy one get one offer is there for you. Okay, if you are investing time on Laplace transform, same concept is going to come in Z transform. Here in Laplace transform, what will happen? The signal is multiplied with e power minus sigma t, and in Z transform, in discrete it is multiplied with r power minus n. For ROC here we will look for the values of sigma. In Z transform we look for the values of r. So try to concentrate on Laplace transform. Z transform will become easy for you. Okay, come to this one. So if I take this signal e power minus 2t u of t, what is the Laplace transform? From the previous knowledge, we will say that this e 1 by s plus 2, ROC is what? Sigma greater than minus 2. ROC is sigma greater than minus 2 we will say. Observe here carefully. Now, how draw the pole zero plot first. Now we are trying to understand the concept of ROC. This is real axis, this is imaginary axis. So in Laplace transform we have included this axis, real axis here, so that this became a complex frequency plane. Now where is the pole located? Where is the pole located? Pole is located at s is equal to minus 2. I don't have any zeros. Okay. Now along this pole, draw a dotted line, bypass the pole, and we'll say that this is ROC. This is what is your ROC. ROC means what? Region of convergence. ROC means region of convergence, means here in this region your Laplace transform is convergent. In this region the Laplace transform is convergent, whereas in this region your Laplace transform is divergent. See, in this region your Laplace transform converges, whereas in this region Laplace transform diverges. This is 1, this is 2, I'll say. In the region 1 Laplace transform will converge, whereas in region 2 Laplace transform will diverge. How can you say? We know that Laplace transform convergence is based on what expression? X of t e power minus sigma t. After multiplying your x of t with e power minus sigma t, the resulting signal must be absolutely integrable. This is the convergence condition for Laplace transform. Remember, after multiplying your x of t with e power minus sigma t, the signal must be absolutely integrable, right? Now I'll do one thing. I'll take one value of sigma in the region 1. Sigma is equal to minus 1. I'll take one value of sigma in the region 2, minus 3, right? I took two values. Now we know that convergence of Laplace transform is based on this expression, no? So multiply, this is my x of t. Now do one thing, multiply your x of t with e power minus sigma t. What is x of t into e power minus sigma t here? In the first region, x of t e power minus sigma t is x of t is e power minus 2t u of t I took. E power minus sigma t means e power t. Minus sigma, no? So e power t. So what it will become? E power minus t u of t. So which is a decaying exponential. Yes, decaying exponential means convergent. Now perform the same in the region 2. Perform the same in the region 2. So you try to find out what is x of t e power minus sigma t in the region 2. In the region 2 what will happen? X of t is e power minus 2t u of t into e power minus sigma t. Sigma is minus 3, no? So e power 3t. This is e power t u of t, which is a growing exponential. Growing exponential means what? Not absolutely integrable. So whatever the value of sigma, if you are taking in the region 1, Laplace transform is convergent. Whatever the value of sigma you are going to take in the region 2, the Laplace transform is divergent. This is for a infinite duration signal, because e power minus 2t u of t is a infinite duration signal. It is not a finite duration signal. Infinite duration signal. Then what about a finite duration signal? What about a finite duration signal like impulse signal? Look here. See what I said in Laplace, before coming to Laplace transform, our del of t is del of t only. After coming to Laplace transform, this del of t gets multiplied with e power minus sigma t. Now we have to check the values of sigma for which this expression del of t e power minus sigma t converges. Now I'll do one thing. I'll take a value of sigma greater than 0. I'll take a value of sigma greater than 0. Sigma is equal to 3 I'll take. So this becomes a del of t e power minus 3t. And we know that from the properties of impulse signal, if you multiply as impulse signal with any signal, we'll get the same impulse signal, but its area will change according to the signal. So here, look here, we have this property now, x of t into del of t is nothing but x of 0 into del of t. So e power minus 3t into del of t is nothing but e power minus 3 into 0 into del of t, which is nothing but del of t. So if I take the values of sigma greater than 0, that is sigma is equal to 3. So I got del of t into e power minus 3t, which is nothing but del of t. So we know that del of t means what? Absolutely integrable. Yes or no? Del of t is absolutely integrable. Absolutely integrable means absolute area under the signal must be finite. Yes, impulse signal means its area is 1. It is absolutely integrable signal. Now you can take any value of sigma greater than 0. Sigma is equal to 3, but for the sake of convenience you can take a complex value also. See, in S-plane, sigma greater than 0 can correspond a complex value also. 1 plus j you take, 100 plus 100j you take, okay, 100 plus 5j you take, your wish. You can take any complex value also. Now sigma less than 0 if I take. So I don't have any problem if I take the values of sigma greater than 0. Now what will happen if I take sigma less than 0? Sigma is equal to minus 3. So in Laplace what will happen? Del of t e power minus sigma t means e power 3t. Right? According to this property, this is again del of t, which is absolutely integrable. Del of t is absolutely integrable. So I can take any value of sigma less than 0. I can take any value of sigma less than 0 also. Now sigma is equal to 0 you take. Sigma is equal to 0 you take. Sigma is equal to 0 means del of t into e power minus sigma t becomes del of t into e power minus sigma t becomes a del of t only, which is absolutely integrable. Which is absolutely integrable, right? Or you can take any imaginary value, your wish. You take the value of sigma to be any imaginary value. So the resulting signal will be absolutely integrable. Now if we summarize, look here. This is your S-plane we are saying. Sigma greater than 0, look here. Sigma greater than 0 corresponds to right half of S-plane. This is S-plane, complex S-plane, this one. Now I can take for impulse signal, look here, for this kind of finite duration signal, I can take the value of sigma, any value of sigma greater than 0. Greater than 0. It may be a complex value, it may be a real value, any value. So sigma greater than 0 corresponds to right half of S-plane. Right half of S-plane, any value, any value. So no problem for sigma greater than 0. Now sigma less than 0 corresponds to left half of S-plane. I can take any value of sigma left on the left half of S-plane also, including complex values. And I can take any value on the imaginary axis, no problem. So all put together, entire S-plane. You can take any value of sigma in the entire S-plane. So we'll say if the signal is of finite duration, ROC is entire S-plane. ROC is entire S-plane means, look here. See, in Laplace transform, we are going to multiply the given signal with e power minus sigma t. So what are the bounds on sigma we are going to examine? For a finite duration signal, like impulse signal, there are no bounds on sigma. You can take any value of sigma on the entire S-plane and you can multiply so that the resulting signal will definitely converge. So ROC is entire S-plane. But if you have an infinite duration signal like this, so we cannot take any value of sigma. I can take the value of sigma greater than -2 only here. That is the essence of ROC. If you have any doubt, you can take a finite duration signal and you can multiply and you can verify whether the resulting signal is absolutely integrable or not. For a finite duration signal, I can take any value of sigma greater than 0. any value of sigma less than 0. I can take any value on the imaginary axis also, all put together, entire S plane. You can take any value of sigma in the entire S plane, entire S plane. So, conclusion is Laplace transform of del of t, impulse signal is 1, ROC is entire S plane, ROC is entire S plane, we will say. If the signal is of finite duration and if the signal is absolutely integrable, let me tell you that ROC is entire S plane. Entire S plane means I can take any value of sigma in the S plane. Hope everybody is comfortable in calculating the ROC. Any signal is given, multiply the signal with e power minus sigma d. Check the values of sigma for that for which the expression converges. Junaid, I think there is a ongoing class for engineering mathematics. I think it is in the evening session, evening at 11 p.m. on the same Kreatryx channel. Vishal sir is taking engineering mathematics. Please attend the class. Junaid, there is an ongoing class. Okay, now let's discuss some properties of Laplace transform. Properties of, all of you put the subheading, properties of Laplace transform. See, what is the significance of these properties? They make our life very easy. We need not find out the Laplace transform using the analysis equation, analysis equation. Using the properties, you can get the answer. So, the first property is linearity. Linearity. This property says that if the signal x1t forms a Laplace transform pair with x1s with ROC R1, x2 of t forms a Laplace transform pair with x2 of s with ROC R2, then the linear combination ax1 of t plus bx2 of t forms a Laplace transform pair with ax1 of s plus b x2 of s with ROC containing R1 intersection R2, with ROC containing R1 intersection R2. See, the statement containing R1 intersection R2 is very, very important. What is the significance of this? We will see. ROC containing R1 intersection R2. Okay, first problem. I think you might have remembered the linearity property of continuous time Fourier transform. Now the first problem is x of t is equal to 3 e power minus 2t u of t minus 2 e power minus t u of t. 3 e power minus 2t u of t minus 2 e power minus t u of t. Now I want to find out the Laplace transform and specify the ROC for the resulting signal. Now how we are going to find out? X of s is equal to 3 times What is the Laplace transform for e power minus 2t of t? 1 by s plus 2. What is the ROC? Sigma greater than minus 2 minus 2 times 1 by s plus 1. What is the ROC? Sigma greater than minus 1. Or if you simplify this one, you will be getting s minus 1 upon s plus 1 into s plus 2. S minus 1 upon s plus 1 times s plus 2. Now, always I said, whenever you are going to get the Laplace transform, we must specify the ROC also. How to get the ROC? In order to get the ROC, first of all, we will try to draw the pole 0 plot. For that, take the complex S plane. Okay, I took. So, real axis, imaginary axis. Now, locate the poles and zeros. Zeros are nothing but the roots of the numerator. So, there is a 0 at 1 and we have one pole at minus 1, the other pole at minus 2. Now, if you observe, our problem is nothing but the linear combination of two signals, and what we have seen, linear combination means you have to take the common ROC. First of all, what is the ROC for the first one? Sigma greater than minus 2, means from minus 2 to infinite. What is the ROC for the second signal? Sigma greater than minus 1. Now, what is the common ROC? So, sigma greater than minus 1. Common ROC is sigma greater than minus 1. This is the ROC. See, already we discussed ROC should not contain any poles, but ROC may contain zeros. Look here, zeros may come into ROC, but poles should not come into ROC. So, what is the final ROC? We can write here sigma greater than minus 1, right? See, the meaning is you can take any value of sigma greater than minus 1 and you can multiply the signal x of t so that the resulting signal will converge. You can verify also. After the class, you do one thing. Take one value of sigma greater than minus 1, 2, 3, take some value, multiply the signal x of t with e power minus sigma t and see whether the resultant signal converges or not. So, this Laplace transform is saying that you can take any value of sigma here, any value of sigma greater than minus 1. Okay. Now, the next signal is, I want the Laplace transform for this signal, minus 3 e power minus 2t u of minus t plus 2 e power minus t u of minus t. I want the Laplace transform for this signal. Now, the first observation is, look here, in the previous example, look here, both the signals we have u of t. Now, here in both the signals you have u of minus t, or I can say that, look here, in the first signal, both the signals are right sided. Right sided means, look here, whatever may be the starting point, if the signal is going towards plus infinite, it is known as right sided signal. In the first unit we have seen right sided signal. Here both the signals are right sided, whereas here both the signals are left sided. Now, how to find out the Laplace? Look here, what I will do is, I will try to, before calculating the Laplace, I will try to arrange my signal like this. Can you write like this? Yes. Take minus common again, minus e power minus t u of minus. Can you write like this? Yes, you can write. And we have seen that e power minus at u of t and minus e power minus at u of minus t, these two signals are having same Laplace transform, but they differ in ROC. So, What is the Laplace transform for this one? 3 times 1 by s plus 2 only, but with ROC sigma less than minus 2 minus 2 times. What is the Laplace transform for this one? 1 by s plus 1, but with ROC sigma less than minus 1. Now if you simplify, again you are going to get the same expression what we got in the previous case. But Laplace transform we got means we must get the ROC, no? For that ROC, plot the pole 0 plot. Real axis, imaginary axis. So look at the poles. 0 is located at 1, 1 pole at minus 1, 1 pole at minus 2. Okay. Now for the first signal, what is the ROC? Sigma less than minus 2. For the second signal, sigma less than minus 1. As we are having linear combination, we must take the common ROC. Common ROC is what? Sigma greater than minus 2. Sigma, sorry, less than minus 2. That's it. Next problem after this. Sorry, x of t, this one. So first of all, try to arrange your signal as per your convenience. So whenever you have u of t, okay, you can simply write it e power minus 2 t u of t. Whenever you have u of minus t here, try to arrange like this, so that we can use standard expressions of Laplace transform. Now what is the Laplace transform? 3 times 1 by s plus 2. What is the ROC? Sigma greater than minus 2 minus 2 times 1 by s plus 1 sigma less than minus 1. Right? Now if you simplify, you will get the same Laplace transform as the previous case. S minus 1 by s plus 1 into s plus 2. But what is the ROC? For that, draw the pole 0 plot. So one pole is located at minus 1, the other pole is located at minus 2, 0 is located at 1. Now sigma greater than minus 2. Sigma greater than minus 2 means from minus 2 to infinite, like this. Any value of sigma greater than minus 2. Sigma less than minus 1. Now what is the ROC? Common ROC. We know that for linear combination we must take the common ROC. Common ROC is between minus 2 to minus 1. After the class you can verify. So here for this signal, for the Laplace transform of this signal to converge, I must take the value of sigma between minus 2 to minus 1 only. If I take the values greater than minus 1 or less than minus 2, so Laplace transform will not converge. After the class verify, multiply the signal with e power minus sigma t. So in that sigma you take the values of sigma greater than minus 1, less than minus 2 and see whether it is converging or not. That is the best practice. So here what is the ROC? Between minus 2 to minus 1. Minus 2 less than sigma less than minus 1. After this, one more, minus 3 e power minus 2t u of minus t minus 2 e power minus t u of t. I want the Laplace transform for this signal. So how you are going to find out? So u of minus t is there, no? In the first in the first signal you have u of minus t. So try to arrange like this. So this is minus e power minus 2t u of minus t minus 2 times e power minus t u of t. Laplace transform 3 times 1 by s plus 2 sigma less than minus 2 is the ROC minus 2 times 1 by s plus 1 sigma greater than minus 1. Now if you observe here, according to the property of linearity, I must take the common ROC. Is there any common ROC between sigma less than minus 2 and sigma greater than minus 1? Sigma less than minus 2, if you take the S-plane, see this is your S-plane. So one pole at minus 1, the other pole at minus 2, 0 at 1, no? So sigma less than minus 2, sigma less than minus 2 means this portion, sigma greater than minus 1 means this portion. Is there any common ROC? No common ROC. No common ROC means, remember, no Laplace transform. No Laplace transform. We cannot find out the Laplace transform for this signal. Laplace transform does not exist. Remember, for linear combination you must have common ROC. If common ROC is not existing means you cannot find out the Laplace transform. Individually this signal will have Laplace transform, this signal will have Laplace transform, but in order for their linear combination to have Laplace transform, they must possess common ROC, otherwise we cannot find out the Laplace transform. Now one more justification is also we can give here. Look here. Here from this problem, can I say one statement that if your signal is linear combination of two signals, if our signal is linear combination of two signals of which both are right sided, look here, this is right sided, this is right sided, then ROC is right side of the rightmost pole. Look here, ROC is right side of the rightmost pole. If the signal is linear combination of two signals of which both are right sided, this is right sided, this is right sided, then ROC will be right side of the rightmost pole. ROC will be right side of the rightmost pole. Observe. Now if your signal is linear combination of two signals of which both are left sided, look at, both are left sided. Now here what will happen? ROC is left side of the leftmost pole. ROC is left side of the leftmost pole. ROC is left side of the leftmost pole. If your signal is linear combination of two signals of which one signal is right sided and the other signal is left sided, then ROC becomes a strip. ROC is a strip in the S-plane, strip in the S-plane, strip in the S-plane. Okay, ROC is a strip. And one more point we learned that for linear combination, if you don't have any common ROC, Laplace transform does not exist. Laplace transform does not exist. For linear combination, you must have common ROC. Look here. If I take this signal x of t is equal to 1 for all t, what is the Laplace transform? 1 means from your first unit, how can you write? 1 can be written as 1 is nothing but u of t plus u of minus t. 1 is nothing but u of t plus u of minus t from the first unit. U of t plus u of minus t. Now we'll see what is the ROC for u of t, sigma greater than 0. What is the ROC for u of minus t, sigma less than 0. Is there any common ROC? No common ROC, no Laplace transform, no Laplace transform. Right? In mathematics or the other subjects will study that Laplace transform. One is 1 by s, no, that is unilateral Laplace transform. Remember, the Laplace transform what we are discussing now here is bilateral Laplace transform. See, unilateral Laplace transform means limits are considered. This is our Laplace transform. Bilateral, now we are discussing bilateral Laplace transform. We have one more type of Laplace transform known as unilateral Laplace transform. From 0 minus to infinite, x of t e power minus st dt. Unilateral Laplace transform. So in mathematics, the Laplace transform what you are going to perform is unilateral Laplace transform. So bilateral Laplace transform 1 does not exist. Anyway, we have separate discussion on unilateral Laplace transform. Separate discussion is there. We are going to discuss unilateral Laplace transform also in detail. So coming to bilateral Laplace transform, where we are going to take the limits from minus infinite to infinite. So here Laplace transform 1 does not exist. Right? In the same way, if I take x of t is equal to signum t. Signum t. From the first unit, signum t u of t minus u of minus t, signum t. ROC for u of t, sigma greater than 0, u of minus t, sigma less than 0, no common ROC, no Laplace transform. Laplace transform for signum t does not exist. Does not exist. We cannot find out. The bilateral Laplace transform, in particular the bilateral Laplace transform of 1 or signum t. Signum t. Suppose if I have the signal like this. Del of t plus u of t. Del of t plus u of t. Can I find out the Laplace transform? Observe here. X of s is equal to del of t means 1. What is the Laplace transform? Del of t. Impulse signal Laplace transform is 1. ROC is what? Entire S plane. U of t means 1 by s. ROC is what? Sigma greater than 0. Linear combination of signals, take the intersection of ROCs. Entire S plane intersection, sigma greater than 0. Sigma greater than 0. So the Laplace transform is 1 plus 1 by s with ROC sigma greater than 0. Suppose if I take this signal, xt is equal to del of 3t plus u of 3t. If I take this signal, now what is the Laplace transform? Xt is equal to del of 3t. From the properties, you have to use the properties of impulse signal. Del of 8 is what? Del of 8 is 1 by mod a del of t, no? So this is 1 by 3 del of t plus u of 3t, u of alpha t. Look here, u of alpha t, where alpha is greater than 0 is u of t only. U of alpha t, where alpha is greater than 0 is u of t only. So u of t, u of 3t is nothing but u of t. Now find out the Laplace transform. 1 by 3. What is the Laplace transform for del of t? 1. ROC entire S plane. U of t 1 by s. ROC sigma greater than 0. Linear combination intersection of ROCs. Or x of s is equal to 1 by 3 plus 1 by s with ROC sigma greater than 0. Sigma greater than 0 means I can take any value of sigma greater than 0 and multiply. I can take any value of sigma greater than 0 and I can multiply this x of t with e power minus sigma t, so that the Laplace transform is convergent. Clear? Next question. Xt is equal to e power minus b mod t. Xt is equal to e power minus b mod t. Xt is equal to e power minus b mod t. Take b greater than 0. B greater than 0. I want the Laplace transform and the associated ROC. Try to solve this problem. E power minus b mod t, b greater than 0. First of all, you must expand this one, no? E power minus b mod t. In the first unit we have seen e power minus b mod t is what? For b greater than 0 it is a double-sided exponential non-causal signal e power minus bt u of t plus e power bt u of minus t. This is the expansion. First of all, you must know this expansion. What is the shape of the signal? E power minus bt u of t for b greater than 0, like this. E power bt u of minus t for b greater than 0. This is e power bt u of minus t. Right? Now, find out the Laplace. But before finding the Laplace transform, let's rearrange. Here e power bt u of minus t is there. No, whenever you have u of minus t, try to arrange like this. Okay. Now Laplace transform. 1 by s plus b sigma greater than minus b minus 1 by minus e power bt u of minus t s minus b ROC sigma less than b. Or if I simplify this one, I will be getting, what is that I am going to get? I think it is minus 2b by s square minus b square. Minus 2b by s square minus b square. Now, in order to get the overall ROC, let's draw the pole 0 plot. Right? Now, one pole is located at b and the other pole is located at minus b. So, what he said, b greater than 0, he said no. He said b greater than 0. Take some value of b greater than 0, your wish. 2, 3 something, or let me simplify this one, minus 2b by s plus b into s minus b. There are no zeros, only poles are there. So, one pole is located at b. B greater than 0 means this one. See, the one pole is located at minus b. So, let me come like this. Observe here. One pole is located at minus b. Suppose b is greater than 0. Say some value of b to be 2. B greater than 0, he said no. Say take some value of b greater than 0. Now, sigma greater than minus b means first pole is located at minus b, means minus 2 here, from which ROC is right sided. And the other pole is located at b, means 2 will lie here, from which ROC is left sided. So, what is the ROC? Between minus b and b. So, this is ROC. So, ROC here is minus b less than sigma less than b. Minus b less than sigma less than b. always in Laplace transform we must write the ROC. See, in exam they may ask like this, what happens if B, see here what I said, B greater than 0 I said, what happens if B less than 0? Let's analyze. X of t is equal to the same e power minus B mod t. B less than 0 if I take, what will happen? So first of all try to expand this one. This is e power minus bt u of t plus e power bt u of minus, this is expansion. Now what is the shape of the signal in time domain? In time domain, okay, b less than 0 means take some value of b less than 0, minus 2 or something. Suppose b less than 0, say b is equal to minus 1 I took. What will happen to the first signal? So e power t u of t, it will be like this. Second signal, e power minus t u of minus t. This is the shape of the signal in time domain. Time domain. Now, if you try to calculate the Laplace transform, x of s is equal to 1 by s plus b for sigma greater than minus b minus 1 by s minus b for sigma less than b. Now, if you try to observe in S domain, S plane will plot, look here, one pole is at minus b, look here, one pole is at minus b. Where is the first pole located? Look here, S is equal, where is the first pole located? At S is equal to minus b, but b is what? Minus 1 I assumed, because b must be less than 0, no? First pole is located at minus b, where b is minus 1 means here it will come. From which ROC is right sided. Right sided. Now the second pole is located at B, means B is minus 1 means here. From which ROC is left sided. Left sided. Is there a common ROC here now? Is there a common ROC? No common ROC means no Laplace transform. So if I take B less than 0, we will not have any Laplace transform. Understood? So always we must take b greater than 0. Now we have seen so many examples. Now my question is like this. Look here. Now we have an interesting question. All of you must be ready. You must give answers for each of the following. Integrals. Specify the values of the real parameter sigma, which ensures that the integral converges. Which ensures that the integral converges. First one, 0 to infinite e power minus phi t power minus of, come on, try to answer this one. Read the question first. For each of the following integrals, Specify the values of the real parameter sigma which ensures that the integral converges. Integral converges. Come on, tell me how to solve this one. See, based on what values of the real parameter sigma, this integral converges. Come on. What happened? Now, okay, I will tell you the first one. This is nothing but sigma plus j omega is nothing but yes, no. So, this is nothing but integral 0 to infinite e power minus phi t into e power minus st dt. Or this is nothing but, look here, whenever you are going to calculate from 0 to infinite, so this is nothing but the Laplace transform of e power minus phi t u of t. Indirectly, it is asking us to calculate the ROC. Laplace transform of, this is nothing but Laplace transform of e power minus phi t u of t, no. So, e power minus phi t u of t, what is the ROC? Or e power minus phi t u of t, this will be multiplied with e power minus sigma t. Now, this will become e power minus of sigma plus 5 into t u of t. This has to converge. Converge means sigma plus 5 must be greater than 0. Sigma greater than minus 5. This will be your answer. Yes, Harish, your answer is right. Sigma greater than minus 5. You must write real part of S. You are written yes. Sigma or real part of S. Now the second one. Second one. Tell me. Minus infinite to 0 e power minus phi t into e power minus sigma. Come on, tell me what is the value of sigma? No. What could be the value of sigma such that this integral converges? Very simple, yaar. I am waiting for your answers. See, minus infinite to 0 e power minus phi t into e power minus st 0 means e power minus st dt means this is Laplace transform for e power minus phi t u of minus t. Right. Now, this has to, for this Laplace transform to converge, Laplace transform, what will happen? This e power minus phi t u of minus t will be multiplied with e power minus sigma t. So, this is e power minus of sigma plus 5 into t u of minus t. U of minus t means sigma plus 5, let me tell you. What is signal? E power minus of sigma plus 5 into t u of minus t. Now, this has to converge, means what could be the values of sigma plus 5? See, sigma plus 5, suppose you can verify, experiment here, as we are in learning stage, experiment. Take sigma plus 5 greater than 0, sigma plus 5 less than 0 and try to draw the signal. Sigma plus 5 greater than 0 means, tell me some value, greater than 0, 2. So, my signal becomes e power minus 2t u of minus t. What is shape of this signal? E power minus 2t means this one, this kind of shape. U of minus t means this kind of shape. If I multiply, multiplication of signals is nothing but multiplying at common points, so that the resulting signal will be like this. So, this is not convergent, this is divergent. So, this is ruled out. Sigma plus 5 less than 0, take minus 2. Minus 2 means sigma plus 5 is minus 2 means this becomes e power 2t u of minus t. Okay, e power 2t means this is the shape. U of minus t means this is the shape. Multiply. Now, if I multiply these two signals, the resulting signal will come like this. Yes, this is converging towards minus infinite. So, sigma plus 5 must be less than 0 or sigma less than minus 5 is the answer for the second one. Second one. Junaid, your answer is right. Harish, your answer is right. Vamsi, sigma less than minus 5. Yeah. Third one. Okay, third one, don't worry. Try to answer the third one. Minus 5 to 5 e power minus 5t into e power minus of sigma plus j omega into t dt. Come on, you tell me for this one. Minus 5 to 5 e power minus 5t e power minus of sigma plus j omega into t dt. Come on, come on, come on. What is the value of sigma such that this integral converges? We'll tell you, Sai Prasanna. We'll be doing Fourier series in a big way. Don't worry. Minimum 10 to 15 days we'll be concentrating on Fourier series only. What is the value of sigma? No answers. What happened? Minus 5 to 5. Harish, think for once. How come minus 5 to 5? How come minus 5 to 5 are? See, minus 5 to 5 means he's integrating means our signal is a finite duration signal. Our signal is a finite duration signal. Sir, no. See, in the previous cases, what happened? We are integrating 0 to infinite means infinite duration signals. Minus infinite to 0 also infinite duration signal. This is a finite duration signal. So, finite duration signal, what is the ROC? Finite duration signal, what is the ROC? Entire S plane. Entire S plane. So, sigma value is any value of sigma. Entire S plane. So, here the answer for this one is any value of sigma or entire S plane. Because as we are calculating the limits from minus 5 to 5, see our signal will be like this. Minus 5 to 5, no? Look here, u of t plus 5 minus u of, can I write like this? That my signal is from is of this kind. Arey yaar, suppose if you are given this kind of signal, xt is equal to e power minus 5t into u of t plus 5 minus u of t minus 5. How you are going to find out the Laplace transform? First of all, we must get the limits, no? So, this is nothing but e power minus 5t. U of t plus 5 minus u of t minus 5 means it exists from what value to what value? Minus 5 to 5. So, this is a finite duration signal. ROC is entire S plane and absolutely integrable also. Understood? Okay, next one, fourth one. Only 5 seconds time here. I will see who will answer this one. I want the answer for this one. What is the value of sigma? Come on, use your knowledge and try to tell me the answer for this. Any answer? I gave 5 seconds, you are taking 5 minutes. Okay, observe here. Here the signal is existing from what were here in the Laplace transform. This is an expression for Laplace transform. First observation is, can I say that this is expression for Laplace transform? Because if I replace the sigma plus j omega with s, this is nothing but the expression for Laplace transform. In the expression for Laplace transform, if he is taking the limits from minus infinite to infinite, what does that mean? That means that the signal is existing from minus infinite to plus infinite, or our signal is nothing but e power minus phi t. E power minus phi t. E power minus phi t, the signal existing from what value to what value? What value, what value? This is a signal existing from minus infinite to plus infinite. And remember, for these kind of signals, we will not have Laplace transform. Bilateral Laplace transform we cannot calculate. See, why we cannot calculate the Laplace transform of 1? Observe here. Why we cannot calculate Laplace transform of 1? 1 exists from what value to what value? Minus infinite to infinite. Remember, if a signal is existing from minus infinite to plus infinite, we cannot find out the bilateral Laplace transform what we are discussing here, because 1 can be written as u of t plus u of minus t. Linear combination I wrote, but linearity says that I must have a common ROC. So in Laplace transform what will happen? I'll multiply this with sigma t, this with also e power minus sigma t. Here sigma must be greater than 0, here sigma must be less than 0, so that I cannot have any common value of sigma, so that Laplace transform of this 1 does not exist, which exists from minus infinite to plus infinite. In the same way, e power minus phi t also exists from minus infinite to plus infinite, so its Laplace transform will not exist. Suppose if I ask you in a similar fashion, what is the Laplace transform for cos omega naught t? If I ask you, first of all, observe the existence. Cos omega naught t is existing will be existing from minus infinite to plus infinite, because u of t, u of minus t, nothing is there. So Laplace transform does not exist. Everlasting signals, Laplace transform does not exist. Sin omega naught t u of t, this also exists from minus infinite to plus infinite. Laplace transform does not exist. But look here, interesting thing is, look here, cos omega naught t, which exists from minus infinite to plus infinite, bilateral Laplace transform does not exist, but cos omega naught t u of t will have Laplace transform. This will have Laplace transform, because this signal is existing from only from 0, no? Then you can find out the Laplace transform. But if the signal exists from minus infinite to plus infinite, sorry, we cannot find out the Laplace transform. So here the signal what I gave is existing from minus infinite to plus infinite. Right? See, e power minus phi t, you can observe in this way also. E power minus phi t can be written as e power minus phi t multiplied with 1. Okay, e power minus phi t, 1 means u of t plus u of minus t, or your signal can be visualized as e power minus phi t u of t plus e power minus phi t u of minus t, u of minus t, right? So e power minus phi t u of t means what? Laplace transform. Laplace transform sigma greater than minus phi. For this one, What is the Laplace transform for this one? Sigma less than minus 5. No common ROC, no Laplace transform. No Laplace transform. Understood? Fifth one. Come on, tell me. See, you try to please correct the statement here what I told you, everlasting signals, no? So, not all everlasting, some everlasting signals will have Laplace transform. Correct the statement here. I told you, no, if the signal is everlasting, we cannot have Laplace transform. I told you, please correct that. If the signal is everlasting, for everlasting signals also we can find out the Laplace transform, because this is everlasting signal. We can find out the Laplace transform. Small correction in the statement. Come on, you tell me what is the value of sigma? Here, what is the signal? Signal is e power minus 5 mod t. We have seen e power minus b mod t, where b is greater than 0. If b is greater than 0, forms a Laplace transform pair with minus 2b by s square minus b square, and the ROC is minus sigma less than b less than minus b less than sigma less than b. In the same way, e power minus 5 mod t will also have Laplace transform, as what is there in place of b? B is 5, which is greater than 0. Minus 2b means minus 10 by s square minus 25 minus 5 less than sigma less than 5. This is the value of sigma. Minus 5 less than sigma less than 5. The last problem. Come on, tell me what is the answer? Limits are considered from minus infinite to 0. Minus infinite to 0. So what this is, this is nothing but yes, means he is asking us to calculate Laplace transform. So e power minus 5 mod t, e power minus 5 mod t, what this will become? Can I say that he is simply asking us to calculate the Laplace transform for e power 5 t u of minus t? No Laplace transform. How come, Harish? Look here, Harish, minus infinite to 0, e power minus 5 mod t. E power minus 5 mod t means what? E power minus 5 t u of t plus e power 5 t u of minus t. So from minus infinite to 0, integration limits are here, means we can, this is equivalent to this one, e power 5 t Means he is simply asking us to find out the Laplace transform of e power phi t u of minus t. Now we know that minus e power a t u of minus t Laplace transform is 1 by s minus a, ROC is sigma less than a. So in the same way, e power phi t u of minus t Laplace transform would be minus 1 by s minus phi. It will become sigma less than phi. Javed, please verify. Javed. Sigma less than phi, not minus phi, it is sigma less than phi. That's all for tomorrow, today's class. Here a small correction, as I said previously. Here I said one statement that everlasting signals means it will not have Laplace transform. I mean, please correct it. Everlasting signals will also have Laplace transform based on the ROC. You must have analysis like this. Better to have analysis like this. Okay. Shall I give you a homework problem? See, I'm giving you a homework problem. Consider the signal x of t e power minus phi t u of t plus e power minus beta t u of t with Laplace transform x of s. What constraints must be placed on real and imaginary values, real and imaginary values of beta such that the Laplace transform of x of s is a real part of s greater than minus 3. Real part of s greater than minus 3. So this is a homework problem. Try to solve this homework problem. Tomorrow, if try to solve this one. If you are not getting, we'll try to solve in the next class. And those who are coming new, join the Telegram group KVS_gate. And these are our channels. And you can follow me on Unacademy, unacademy.com/KVSwamy, and join my Telegram group KVS_gate. And finally, thank you, my dear students. Tomorrow, we'll be discussing the rest of the problems in linearity, and we'll discuss time shifting and time scaling properties. Okay. Until then, stay safe, take care, and happy learning. Thank you.